So let's go ahead and put together the 32K RAM PCB today. Not many parts, a couple decoupling capacitors, some IC sockets, got a couple logic gates that we need to install. One of them is the hex inverter buffer and the other one looks like an OR gate to me. Alright, so let's get started. We'll put the pieces that are closest to the board after they're installed in first, which are our decoupling caps. Not bad. Alright, so that should be the memory, the RAM. O2 is the 32. Make sure you don't get these mixed up. So let's see, U302, looking at the schematic, I see that it is the OR gate. So it's going to go here. Don't want to get those mixed up. And then we've got our hex inverter buffer. Okay, there we go. All right, we'll go back to the computer, take a look at the schematic. I'll explain to you what this module does, how it works, and we'll see about testing it as well. All right, so let's take a look at the circuitry for the 32K Z80 RAM PCB. I kind of laid this out just like I did the last one, and there'll be a PDF link if you want to download it. What's really interesting is if you take a look at the address lines, look what's going on here. Now remember, I've kind of marked them here, so it makes it easier to remember, but a lot of these are active low. So the chip select is actually active low, meaning that when it has a 0 voltage or a low on it, that's what selects it, which means if you have a 1 coming in, a high, it becomes a 0. So that means that this whole block of memory, this 32K, is going to be above 8,000 hex. So our RAM is at 8,000 hex. Below that's going to be our ROM. So that's interesting to note. The other thing is the logic that drives if we're doing a read or a write, and the memory request. Again, all active low. So let's just walk through this really quick. Remember, output enabled and write enabled, those are actually flagged as active low also. So let's see. If we want to do a read, it's active low, so 0 and 0, right? And the write will be high. So if these two are high, and this is a OR gate, this will be high. So write goes high, which means that it's not enabled. But these go low, which means that the read is enabled. As soon as the write becomes low, then you get a low and you go low. So this allows you to quickly determine whether the memory request is going to be a read or a write. And let's see, is there anything else interesting? I think that's pretty much the bulk of it. I mean, the most interesting part of the whole thing is how it pushes. It basically selects where in memory, in the address space, I should say, this memory is going to go. And that is really done by line A15 here. So that's kind of interesting how you can move it around. We could actually move this block of memory into a different location. But knowing stuff about the Z80, when it boots, what memory location it goes to first, those kind of things, that also dictates where that ROM memory needs to be. So anyway, I hope you enjoyed this video. The next one, we're going to put the ROM together. We're quickly getting to the CPU PCB, and then the basic board where we install everything on the bus board. And then we'll actually bring up Microsoft Basic. So we're getting there. All right, guys, hang tight. Hopefully this was a good video for you. Thank you for watching. Remember, learn something new every day. All right, take care, guys.